Hi everyone, my name is Shvetank. I'm a third-year PhD student at Harvard, and earlier today I gave a talk on kind of architecture 2.0 and tried to encapsulate kind of the concept and the vision. Right now in this next 2 minutes, 45 seconds, I'm going to try to just give a little bit of an idea of what we've started exploring to date, which I didn't have the chance to in my talk earlier. So again, just a quick refresher, architecture 2.0 is loosely defined as the era when we use AI and ML methods to minimize human intervention and build more complex and efficient systems in a shorter time frame. And so more broadly speaking, what we're trying to work towards as our North Star is foundation models for hardware design. And so, at some point you can envision something like this where you would prompt some sort of, foundation model to, act like an architect and design a custom processor for you and implement it in a certain node. And again, while this is kind of the North Star and may seem far-fetched, I will now cover where we are today. But it makes sense to first start potentially with embedded systems as a proving ground, especially because embedded systems have a very high NRE cost, especially for the long tail of low-volume applications. And so this is just like a paper from the 90s from Bob Rao, who's like a very renowned architect, and here he highlights the fact and the need for basically reducing cost in automation, using automation due to the customization needed for these embedded applications. So what we've done so far is we took CFU Playground, which is basically a full stack open source framework for TinyML acceleration on FPGAs, and so basically all open source tools across the whole stack. And originally, we designed the accelerators manually, and this was just like an intern actually at Google who in just 4 weeks got a 75x speed up doing the manual design. But then we've essentially now created a plugin for CFU Playground to interface the tool with actually ChatGPT and try to replicate the same process. And so here what you're seeing essentially is basically a bunch of prompts and ChatGPT following the same design flow of basically profiling the code actually, and then implementing the hardware accelerator, measuring the speed up, and then eventually even, actually running physical implementation, in this case in the Sky 130 process, and successfully doing so. So, this is just kind of a first proof of concept we're working on. Now we're trying to create a data set to see how we can, evolve and improve this, improve the performance of the model. And so long term, though, we want to kind of see if we can create this LLM playground, which would be essentially an infrastructure for hardware software co-design. And then lastly, you can envision this end-to-end ML-based flow. And thank you.